And finally, just to document something important to me, which is the reason I don't use stinger cables on valve amps to discharge anything. I use a meter, so you can see actual figures and you know the state of play of the actual device as far as the voltage that's on it. And this particular one, as I said in the other videos, I'm going to just flick it off and you'll see how quickly this discharges down from the 215 volts DC that it's got on the rail. So you'll hear the click and just watch how quickly it goes down to zero. So ready? Within easy 3 seconds, that's down to 0 volts on the rail. So that is how I always turn off any valve equipment at all, so that I know that the B plus is 0. And if, as I said before, depending on the design, you may still have capacitors, the filter capacitors, or some other capacitors, not the filter capacitors generally, because they can discharge back through they discharge through the valves while the valves are still conducting and cooling down. So that's why, if the valves are still got enough power to conduct, then the capacitors will discharge through the valves. Now, that's going to depend, bear in mind, that's going to depend on the design of a particular unit. But at least you know that the B plus, if you've got the meter across it, you know that the highest points on a DC circuit, you know exactly what the reading is and what you're dealing with. So if you want to go ahead then and check, obviously you'd want to be familiar with the circuit diagram to be absolutely sure. And then you would use something like my Carlson, which is effectively a stinger cable, but at least this one's actually got something visual, which you can again put through a meter anyway. This is the unit that I built from Mr. Carlson's, Paul Carlson's site 2 years ago or so. So it's got the leads that can plug into a meter, same as here. So you'd actually get a reading of what you're probing across. But these have got the high brightness red LEDs in them, so that it doesn't matter which way round you say go across the capacitor or whatever point in the circuit you're looking across to see if there's any charge on it. You'll see down to less than, I can't remember now when I tested it, but the video is on the site. If you look at the video for the capacitor discharger, and this can handle a discharge voltage of up to 600 volts DC. Whichever way round you've got the probes, you'll see the tiniest, faintest red light as it discharges. Obviously, if there's got full 600 on it, it'll be really bright, but you'll see it go really dim. So that's you can also use something like that if you want to build it, or just use your meter probes. I said, for most people who have a meter or working on valve stuff, then that's the way I do it. I don't mess about with all this stinger cable stuff, because you don't know. You don't know if you've touched something that's a dry joint. You don't know if you've actually got a connection on the circuit that you're reading across with stinger probes, because you've got nothing to visually verify that connection with. You're just hoping that you've touched it, one side to ground and one side to the live side of whatever it is you're touching. And of course, a lot of old amps, depending where you touch, they can have bad solder on top, or it's got the resin is on the top of it and it's insulated, or you're just not pressing hard enough to get a connection through to the metal to actually discharge the units. And to me, that's just crazy, because you've got a false sense of security. Then you go around tapping all the circuits with your stinger cable, going, I've discharged that, and then you might not have done. And you go and stick your fingers in there and touch it yourself and find out, the stinger cable didn't actually work in that case. But at least this way, for sure you've got a visual reading of 0 volts. And for most people, DC voltage, you can start to touch DC circuits. Not that I'm recommending this. I don't want anybody to go and try it. But, once you get down to around, within reason, and, it depends on the resistance of your skin. If you've got dry skin, you're going to be far better protected against shock than if you've got sweaty hands, obviously, because there's also lots of other factors. So you should always be doing your research. Nobody should ever be working on a valve amp without a really good basic knowledge of electronics anyway, but particularly valve amps, and know do all the research you possibly can on the effects of electricity on the human being. And surprisingly, there's not a lot of information when I last looked. I know Great Scott did a video which is on the front page of my website for the electronic stuff, because he actually put himself through a whole set of shock tests with AC and DC, I believe. And then the article that I read that I used to put in front of all of my posts as a disclaimer was a research paper that basically said that as little as 70 milliamps can actually kill, as far as measured current in tests that have been done, because the big problem with valve amps is around about 300 volts, or well, again, around, very loose term, because it depends on lots of factors like skin conductivity and stuff like that. But basically, once you get around 300 volts or more, it can break through the resistance of the skin, in which case now you've got DC potential of electricity flowing in your blood. So you haven't got the protection of your skin anymore as a resistance. So you need to do your research and be confident that at least you understand the worst case scenario or what you're likely to be handling. And in my case, I've always found that, I've touched DC circuits around about 80 volts and I don't feel anything. I've had a few main shocks in my time. I might as well face this towards me and talk to you. But I've had a few main shocks in my time of varying strength, because, again, depending on those factors that I've just mentioned, which is the conductivity on the day. And one morning I grabbed a connector. I wasn't thinking. I was half asleep, had a cup of coffee, and I think it was a Fender valve amp I was working on, and I still had the mains cables connected. And I was on the inside of the amp where the mains connectors come in, and that just had spade connectors pushed on, but they were bare. They didn't have, so say across here, where these are hard soldered, and they've got shrink downs on the neutral here. Well, it was one of those, the newer style, the new IE connectors, the kettle plugs connectors, but the connector connecting to where the plug goes in were the spade types, and they were bare, and one was bent, and just not thinking, because I thought the amp was switched off, and it wasn't. It was plugged in and switched on at the mains, even though it was off on the front. So of course the mains cable's live, which is why you should shrink these down here and here on the mains cables as they go into the fuse, so there's no bare wires on the actual fuse connector where you solder. So you shrink those down, so at least there's no way of being able to touch here. Although obviously in this case I haven't. You can see here where it's actually gone on to the mains voltage, the mains transformer selector strip that decides whether it's a 230, 240, 250 volts mains input, whatever. I didn't, that was already like that, so I had no reason to desolder that, and you can see that goes straight to the mains transformer, the brown wire here. And of course those connections, when it's switched on, those soldered connections are live, so if you touch those and it's plugged in, you're going to get a shock. And I've had probably 3 or 4 working on computers and valve amps, and just general. I think I had one years and years ago working in London, on a chemical stir out. It was an outside mounted plug at a factory, and I was stirring some chemical drums using an electric stirrer, and it was drizzly and bad electronics from a corroded factory, and I had rubber gloves on, and I could feel a short coming through the rubber gloves in the wet. I was starting to feel a vibration, which was really strange. I said, but shock-wise, the last one I touched that Fender amp, and my elbow, that hurt. My elbow was still feeling a bit numb and tingly 45 minutes later. That certainly woke me up, aside from the cup of coffee, that's for sure. So, you've got to just be really careful. Don't ever rush anything on a valve amp. Or any electrical equipment for that matter. You should always be in a relaxed space, because you should be doing it as a hobby to relax, unless it's your job, in which case then you're that's a different story. But then if it's your job, you should be, you should just have routines and practices in place that are second nature anyway, where you You shouldn't have to think about what you should be touching when, and you should always be double checking whether a unit is plugged in, and just get into a certain mindset of habits. Like for that, for instance, although it's switched off, I should have just pulled the plug out so that if I inadvertently plugged something else in and sidetracked later and turned it on. So all of these things are what you need to know before working on any kind of dangerous mains, and particularly DC valve amps that can be anything from, say, like this one, down to 200. This is the lowest one I've ever worked on, at 220 volts DC. I actually think it's probably correct. I don't think there is anything wrong with it now. It just said in the diagram that that's what the early unit that they did that write-up, which is on the PDF of the circuit. That was an early release model. So maybe they changed some resistor values or the rectifier circuit to give out a lower voltage on the actual production units, which is why this one only sits at around 215 volts DC, whereas the one on the PDF, they said it was 325. So, but it seems to work fine. So this is the lowest DC voltage unit I've ever come across as a valve amp. So that Laney Clip and JB's Marshall 100, they were up around 550 volts DC rather. That's a serious bit of kit, and it's not gonna be forgiving at all. That's gonna be pretty tragic stuff if you come across 550 volts DC. So do your research and just get a set of routines that you develop yourself. Double check everything before you work on valve amps, and be careful.